So today we're going to talk about a framework that we've been building called Dora. And yeah, so I'm a freelance, I'm independent, and I'm working on this for about 2 years now. Yeah, in full time. So maybe just a quick update on why do we do this. So basically, we think that there's a real need to make robotics more accessible for anyone. If you did robotics before, you probably needed to code in C and C++, which is pretty hard, and we kind of want to make it a lot more simple. For example, use Python or Rust, which is more accessible than other technologies. The use case are primarily about kind of using DIY robotics hardware. We're not really talking about kind of using really big robots or try to build very custom robots. It's really just DIY things that you can buy off the shelf. So this you can buy on Amazon, and hopefully in the future we can have more and more robots in the same way. Our target audience is probably people who are has an interest in robots, in robotics, but maybe doesn't have the energy to spend weeks coding in C and C++. People in master students, PhD as well. It's kind of our target audience. Maybe before diving too much into details, maybe we can just put some foundation about what exactly do we mean by coding robots. Basically, when you program a robot, it's kind of different than just programming a simple application. The thing is, you want to have multiple loops running in parallel and then talking to each other. So for example, you would want to have your webcam loop pushing you new images every certain frequency. You will have your AI model that will run in its own loop that's going to do some computation, and you want this to be non-blocking from each other. And the thing is, you need to have a way to bound them together and to make them communicate in a way that is very efficient. And so this is what we try to do at Dora. And so for example, we have this concept of nodes, which is basically their own main loop running in parallel, and then we have edges, which is kind of topics where you just define a name, and then the nodes can talk to each other in a publish-subscribe pattern. And so the idea is that how do you define this graph is just using YAML file, kind of you would do with a Docker composer and Kubernetes, and you just say, okay, this is my input, this is what I need, and this is my output, and this is my source code, and then you will be able to run those loops. Now the thing is, to make it very efficient, we need to have a unified way of sharing messages, right? You don't want to have loops talking in one language, another loops talking in another language, and not be able to communicate with each other. And so this is why we use Arrow. I don't know if you heard Arrow before, but it's not just linked to robotics. It's actually something that is used widely in the scientific community. Basically, it defines a unified way to, for example, define arrays. So when we talk about uint8 arrays, it's always going to be the same, a C-shaped array layout, so that if you talk from C and C++ to Rust or Python, you will be able to communicate without having to worry about, are we talking in the same memory layout or not? And this is really good because then there's a lot of libraries that is being built on top of this Arrow memory layout, such as NumPy, which is a very popular library in Python, Pandas, PyTorch, OpenCV, and many more. And the thing is, because you have this all unified memory layout, all those messages can be passed without doing any copies. So you would just say, okay, this is a pointer, just use this pointer, and you don't do any copies. You don't have any serialization, deserialization that you would have with protocol buffers or other type of communication serialization. And this is actually really good, right? Because if you don't know, when you do serialization, you probably need to do some form of copying. And copying can be very expensive, especially if you have very big data, right? So if you start pushing huge video stream, if you start pushing huge LiDAR sensors data, you're talking about hundreds, even megabytes of data each LiDAR point cloud, right? Or if you have, for example, you have a car, you have 10 cameras, you have a small robot like this, you will probably have 4, and then you have a lot of data to pass around. And so if you have any form of copy, you will probably lose up to 20 milliseconds of latency, which can be a lot, right? Because then you have still a lot of processing to do. And then if we think about, all right, if we want to stop this car, you probably want to stop it as early as possible. So we did this, and with Dora, we have very good performance on communication. And this is kind of the big thing that we want to push. And this is one of the reasons why we want people to use Dora. And the thing is, because we use Arrow, because we have this performance, we can now use some form of deep learning models, right? I've listed a couple. I'm gonna do a quick demo because maybe it's gonna talk to you a bit more than just reading a big table like this. But the idea is that there's a lot of models that is already available online that we can use. For example, you probably heard about OpenAI Whisper. It allows you to do speech to text. And so you can just plug it in on a local computer like mine, and you will be able to transform your speech to text. You have VLM models, which is basically just to say that you can push an image and you get text generated out of the image from whatever he understood of the image. And you have some text-to-speech model from Hugging Face. So as Annie said before, actually Hugging Face reached out to me and was really interested in kind of showcasing the models they built in-house. So all those models are in-house deep learning models that you can use freely. It's open source because the data set from underneath is open source. And so yeah, so let me maybe just give you a quick showcase of what it looks like. So we're gonna just do this and then do this. So this is my graph, which is just a definition. You don't have to memorize this by heart. I can share the slides, but basically I'm just saying that there's a couple of main loops. Some will do speech to text, some will do text to speech, and then just by simple definition, I can do, all right, so I'm just gonna do this. All right, is this one? Yes. And then I can just define it in a YAML graph, which I'm not too much going to go into details in. And then what happens is all those nodes will connect to each other, and then I can do a quick demo. So for example, now I have this visualization tool called Rerun, which is also in Rust, also open source. And it's connected to all the different models that I talked before, right? So if I start talking, I will be able to use Whisper and the VLM and Parallel TTS that's going to transform what I said to speech. So for example, if I say, what do you see in the image? It's going to be able to translate what I said to speech into text.
In the image, there is a large room with a concrete floor. The walls of the room are painted white and decorated with...
Right, and so I cut it because otherwise it can talk for a long time. And you probably don't want to listen to a VLM talking, right? We can also try to put something here, maybe like this. I don't know. Yeah, maybe I can put. Okay, maybe you can go in the. Thank you very much, Annie. You can go on the screen, and we can ask any type of. You can just go, yeah, there, and I'm probably gonna say, yeah.
You want me to stand here?
Yeah, if you don't mind. Thank you. Yeah. All right. So. Is there a person in the image? Oh.
In the image, a woman is standing on stage. She is wearing black clothing and has her hands on her hips.
Right. So yeah. And so, for example, we can also map it into like functions, right? We probably want to see it move. So, for example, I can say, so I mapped the yes to like him moving like a noding yes and a no, like a noding no. So I can say, for example, is the woman wearing a blue dress?
The image depicts a scene where a person, likely a
Right,
woman,
so
is
for
standing
example,
on stage.
in this case, we see that it doesn't really answer the question. And so I kind of, it's kind of a bug. So I'm going to turn it into a feature, right? But the thing is, this model Idefix is running on my computer, right? And so it's not as powerful as you would have a GPT-4 vision, a Grok vision, and whatnot. So you have to expect it to not respond in the way that you want, right? Now I want him to respond by yes or no question, so probably I'm going to ask something simpler. Is the person wearing a blue dress? Question mark.
Yes, the woman is wearing
now
a blue
he's
dress.
going to move like up and down, right? But then you can make it move whatever you want, right? And you can map any type of question with any type of answer, right? You can run the model not every time I speak, but all the time, right? And then you can map all the text to any type of function you want, right? So maybe you want, when you go home, you want to be like, if I move my hand like this, get the light, all the lights up, right? And this is totally something that you can map, right? And so that's kind of the thing that is kind of changing, I think. So before, when you were doing AI like this, you would probably have to have some form of bounding box, fixed structured data, and now you have unstructured data as an input for your robotic application. All right. So thank you, Annie. I think we're good. Thank you very much. Yeah.
Really impressive.
Yeah. And so just to go further, now it's not it's just one feature. We have other features. I'm going to name another one now. I'm just going to check the time. Okay. Another feature is that if you did robotics before, or you did any type of programming before, you know that it's very tiring when you have to do a code change to have to reset the application every time, right? It takes a lot of time, and it's even worse if you have a robot, right? Because then you have to switch off the robot, take it back, reset the different sensors, pour it on, and then put it back. And so we built something that we call hot reloading, and you've probably seen this before in web development. Can you see my screen? Maybe. Okay, I'm going to put it bigger, maybe. Okay, there you go. And now, so if I change the code and I save it, so now I'm just doing the LED because it's simpler now, but I can change the code and it's going to change it, the color in real time. And I can do any type of modification, and it's just going to, for example, I want to change the color, it's going to change the color there. And yeah, I can do any type of modification. I can put an if loop, I can put a for loop, I can do any type of thing, and then I will be able to prototype in real time. I can change the model, and we also have a lot of fail-safe mechanism that makes this work in real time. All right, so that's good. Now I'm going to try to do the last slide. Do I have the last slide? Yeah. Yeah. OK, just before this one, there's a demo I want to do, but maybe I think today I'm having some difficulties, so not sure if it's going to work. I'm very sorry if it doesn't. But the idea is that you can do code change, and but the thing is, you probably don't even want to code anymore. Maybe you want to use an LLM to program for you. And that's the thing that I want to showcase. All right, just give me 1 sec. I'm just going to do a quick thing. Let's see. Go to, OK. All right, let's try this. Just give me 1 sec. I'm very sorry about that. All right, let's try this. That's fine. So for example, in kind of a follow-up of what I showed you before, right? Being able to do code modification and then see it in real time. Now in this case, we might want to do what I just did before, which is map some form of vocal command or any form of text into an action, right? It's really something that you want to do at home. And so what I can do is I have a template of a policy. A policy is just to say, OK, in this situation, you do this. And you don't really care about the implementation. You just care about what you should do in which circumstances, right? And so in this demo, what I want to do is be able to code the policy so that I don't have to code myself. So I'm going to start the demo. It's going to start running. All right, just give me 1 sec. It's going to reset. And resetting is there. All right. So this is just a template. Basically, here I'm going to feed him some data about whatever he hear from, the Whisper VLM, Whisper speech-to-text, and then we're going to try to map it to some vocal commands. For example, I may want to make him move into space. So I've told him before that, there's a couple of locations you could go, a kitchen and an office, and I have some preset data inside because how he do the action is not really relevant at this point. And so what I can do is just use a local LLM that is running on my computer again, and just fill in the blanks. So for example, I can say, okay, when I say go to the office, go to the office. And when I say kitchen, go to the kitchen. And so now there's a Whisper model that is going to transform what I said in speech to text, and then there's an LLM model that is able to transform what I said in text into code. And there we go. So if you hear office, he should go to the office. And when he hears kitchen, he goes to the kitchen. And this is running live. And normally, if I say go to the office, he's gonna execute this code. And now he knows that he has to go to the office, but somehow he's not moving. And I think maybe it's because of the travel. So I'm just going to try to debug this real quickly. But yeah, I'm very sorry about that. Kind of a last-minute thing. And yeah, OK. Yeah, I'm not sure about what's happening there, but yeah, I'm very sorry. But yeah, the idea is that you can basically code the LLM at free will and just say to go to some place. So I'm just going to reset the demo and then just go here and then just go there, maybe. Yeah, OK. All right, just go to this and just do. Okay. 1, 1, 0, run. -1. Okay. So I'm just going to fill in the blank myself really rapidly. And self-text. Self-text. Text. Okay. Office. Kitchen. But yeah, but yeah, and so then you can map the different movement to the robot. So I'm just going to try again. And so if I say go to the office, okay, maybe I should try a bit slower. Go to the office, and then he's going to start moving. Okay.
The image captures a
Yeah,
scene
so
in an office setting, possibly during a presentation
and all of
or
this
event.
is coded from the LLM, and yeah, and so basically you can imagine any type of interaction you could do, but this is just for small robots. This is just for small robots. So this is our current state. It used to be very hard to do robotics. It used to be very hard to do robotics. You used to have a lot of very custom robotics field, and now we're trying to replace it with very simple tools that you probably heard about before in different fields. Maybe you heard about Python. It's a programming language. It's very easy, and we don't want compilation. I mean, we want native compilation, so we want cargo, for example, but we don't want to have custom compilation that nobody heard about, like Cocon. We're really working hard as well on integrating robotics into all the other fields. So for example, if you use OpenTelemetry because you have distributed system, you use things like Datadog or Prometheus of Kafka. Those can all be connected to robotics through OpenTelemetry. And yeah, so that's our current state. But that's just now. And the thing is, this is what we did so far. This is how we reached 1,000 stars on GitHub. But we now have bigger plans. And we recently been reached out by Thomas Wolf, which is one of the co-founder of Hugging Face. If you don't know Hugging Face, it's a very big startup that hosts deep learning models and make it very easy for anyone to use deep learning models. And we've also partnering up with someone called Rémi Cadenne, which used to work at Tesla and who's been one of the lead on Optimus, which is a humanoid robots. And we're trying to make everything that is closed source for robotics open source. We're really trying to get all the best ideas that we heard in the closed source community and then just put it there for everyone so that anyone can get started with robotics, that it's not something that is limited for a limited few. And we don't have any incentives except making it all open source. We just really deeply believe that in the vision that robotics needs to be something that anyone can use, right? And because of this, we started working on robotic arm. Yeah, actually, I didn't know robotic arm was a big thing until recently, and we did a lot of progress both in terms of cost and in terms of precision. And now we, oops, sorry. Will I be able to run this? Yes. Oh, okay. If I do this, maybe. Ah, fish. Due to a network error. Okay, so I think I'm just going to connect to the internet real quickly. Do I have my phone? There. And all right, just give me 1 sec. And tack. It's super frustrating to deal with connectivity issues on a slide, but anyway. Okay. Yeah, so we're working on robotic arms, and the thing is, we can actually show him what to do something, record all the data using Dora, with all the benefit of Dora in general, and then if we do teleoperation, we will record this, and then we'll be able to play it back. And if we can play it back, we can map it to a vocal command, we can map it to LLMs, we can map it to everything. And so if you want to be a small Iron Man at home, reach out, and I can give you the tools, and you will be able to run them in your private office if you want to. For example, in this case, I'm getting chocolate, but you can have anything you want. Yeah, and so this is only done in 1 week of Dora, yeah, right? I didn't know this hardware 1 week before. We received it Friday, like 1 week before, and we just did this demo this week. So it's really not complicated. There's actually just 50 lines of code that is controlling the robot, 15 lines of Rust code. So it's probably a bit more complicated, but it's very simple overall. And this is just getting started. So feel free to connect, and then I can just give you more updates later on as it's built up. And yeah, because this is just the beginning. If we just record some data, we replay, it's very simple. The idea is to also build the LLM model end-to-end. And so you will just be able to say, okay, do this, grab the chocolate, and then he will be able to generate his own state of action, right? Kind of like ChatGPT, if you ask him to do something, give me some steps, he will be able to give you some steps. No, our idea is to do the same thing, but with robotic arms. Okay. Yeah. And yeah, but maybe you will be like, oh yeah, but do we really need Dora for that? Maybe we just need something else. Well, the thing is, we can provide like very, very high communication speed. Now, if you take the current main status of this same robotic arm, we can do better. We can do 2 milliseconds communication latency between the two arms, which maybe it doesn't sound like it's a big deal, but it is, because there's some things that you can't do if you don't have a good latency. So if you want to play ping pong, well, you can't really do it if your arm is too slow, right? So that's the thing. We're building very fine-grained data for anyone. We really want to simplify all the complex installation. You probably spend a lot of time debugging a Raspberry. This is the last thing we want you to do. We just want you to be able to just cargo install something, cargo from Rust, and in this case, it's going to work, right? It's in our README, and then if we have this and we have cargo, we can make it cross-platform. You can work on Mac OS, Linux, Windows, ARM, and AMD, and use any language that you prefer. Yeah, so that's kind of the idea. And yeah, so that's all for me. If you have questions, we can talk later. If you're worried about sentient robotics, we can talk about this later as well. It's actually not a joke. We're actually very scared of sentient robotics. I mean, I have a robotic arm just in front of me most of the day, so I'm very afraid of that. But yeah, thanks for listening in any case. Yeah, hope it was inspiring. Yeah.
Any question for Xavier? If not, I have a question. Does
Yeah.
your robot understand French?
I had never tried. I never tried.
Maybe
I
we
have
should
a
try it.
translation thing on my computer. We can try
You wanna try
right
it?
about now, I think.
Yeah.
So, est-ce que tu comprends le français? Fish. I have this whisper that is writing in French, in English.
The image you provided does not contain any text.
So I'm going
It
to
is a
try
scene
to
of an
change.
indoor event,
Okay, you
possibly
can't
a
see my screen.
conference or seminar.
Just going to try to change whisper to French. Tac, 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 tac. Whisper, English, French. Okay, there we go. And now I'm just going to start again. And I'm just going to connect there. Just give me 1 sec. Right. And now I can do this. And I can do, oh, sorry. All right, just give me 1 sec. Est-ce que tu comprends le français? I think it's not that bad. It's not that bad. And the text-to-speech is in English as well, so it's probably why. Yeah. But yeah, that's definitely something that we will be able to do. Yeah.
Awesome.
Yeah. All right. Well, thanks very much for listening. I'll be around if you have any question, and we can connect as well during break.
Thank you, Xavier. Thank you.